Hello YouTube family, welcome back, and let's provide a solution given this nice math problem, which is 3 raised to power p subtract 2 raised to power p is equal to 65. So what is the value of p? Okay, now from what we have here, we have that 3 raised to power p subtract 2 raised to power p, this is equal to 65. Okay, now from this we can express 3 raised to power p as 3 raised to power p. Okay, this is the same thing as, now if you say 2 divided by 2, if you say 2 divided by 2 is the same thing as 1 times p, it's the same thing as 3p. Now subtract 2 raised to power p. Okay, multiply this with 2 over 2. Okay, the same case as we have done here. This is equal to 65. Now from what we have here, applying the indices identity, that a raised to power n, okay, raised to power m, okay, this can be expressed as a raised to power n multiplied by m. Okay, so applying this indices property, we're going to have 3 raised to power p over 2 squared subtract, this is 2 raised to power p over 2, okay, squared, this is equal to 65. Okay, now from what we have here, 3 raised to power p over 2 squared minus 2 raised to power p over 2 squared, this is actually in the form of a squared minus b squared, which is actually the difference of two squares, which can be expressed as a plus b, a minus b. Okay, so applying this in this, property, applying this property, we're going to have, now we have that 3 raised to power p over 2 squared subtract 2 raised to power p over 2 squared. Okay, we can just say, right, 3 raised to power p over 2 be equal to m. Okay, and 2 raised to power p over 2 be equal to n. Okay, so that means we have m squared subtract n squared. Okay, this is equal to 65. Okay, now m squared subtract n squared, this is actually the difference of two squares expressed as a squared minus b squared, which you can express as a plus b, a minus b. Okay, so applying this property, we're going to have m plus n, m minus n, this is equal to 65. Okay, now we can express this, now we can express 65 as basically 13 times 5. Okay, we can express 65 as 13 times 5. Okay, now from what we have, this is the same thing as m plus n, m subtract n, this is equal to 13 times 5. Okay, now from what we have here, we can basically equate m plus n, we can equate this to 13, and m subtract n, this is equal to 5. Okay, now from what we have here, basically m, that's basically m is greater than 0 and n is greater than 0. Now from what we have here, we have two equations. Now we can add these two particular two equations, linear equations. So let's add, we have m plus, that is m plus m, this is equal to 2m, n plus minus n, this simplifies, and then you have 13 plus 5, which is equal to 18. So we divide both signs by 2, so that the value of m is equal to, if you simplify here, this is equal to 9. So this is the value of m. Okay, now let's solve the corresponding value of n. Okay, so we have that if you substitute to one of these equations, we have that m plus n, this is equal to 13. Okay, now from what we have here, this is 9 plus n, this is equal to 13. Okay, so that means n is equal to 13 subtract 9, and that means that n is equal to 4. Okay, now we have the value of m and n. Okay, so let's substitute this back to equation. Now we have the value of m equal to 9 and the value of n equal to 4. Okay, so if you recall, okay, if you recall, we assumed that, right, 3 raised to power p over 2 b equal to m. Okay, and we say let 2 raised to power p over 2 be equal to n. Okay, so let's substitute the value of m and n, okay, respectively. So this is 3 raised to power p over 2. This is equal to m, which is equal to 9. Okay, now from what you have here, we can express 9 as 3 squared, okay, or 3 raised to power 2. Now we'll have 3 raised to power p over 2. This is equal to 3 squared. Okay, now as you can see, the bases are common. Applying the indices identity, if you have a raised to power n, this is equal to a raised to power m. Given the bases are common, the exponent, which is equal to n, should be equal to m. Okay, so applying this property, we'll have p over 2. This is equal to 2. Okay, so we multiply both signs by 2, both signs by 2, so that we'll have p is equal to 4. Okay, p is equal to 4. Now we can also try with n. We have that 2 raised to power p over 2. This is equal to n, which is equal to 4. Okay, now we can express 4 as 2 raised to power 2. Okay, so this is 2 raised to power p over 2. This is the same thing as 2 raised to power 2. And given that the bases are common, applying the indices identity, then we'll have p over 2. This is equal to 2. You multiply both signs by 2, so that we'll have p is equal to 4, which is the same thing as what we have arrived at using the value of m. Now, given the value of p is equal to 4, let's verify if this value of p satisfies the equation. Okay, now let's verify that this value of p, which is equal to 4, satisfies the equation. Okay, so if you recall, we end that 3 raised to power p subtract 2 raised to power p. This is supposed to give us a value of 65. Okay, now from what we have, p is equal to 4. Now this is the same thing as 3 raised to power 4 subtract 2 raised to power 4. This should give us a value of 65. Okay, now 3 raised to power 4, 3 raised to power 4, this is the same thing as 3 times 3 times 3 times 3. Okay, so this is 3 times 3, which is 9. 3 times 3, which is 9. So 9 times 9, this is 81. Okay, so you have 81. Subtract, this is 2 raised to power 4, which you can express as 2 times 2 times 2 times 2. So 2 times 2, this is 4. 2 times 2, this is 4. 4 times 4 is equal to 16. Okay, so this should give us a value of 65. So 81 subtract 16, this is basically 65, which happens to be equal to 65. And that affirms that basically the left-hand side is equal to the right-hand side. Okay, and that affirms that the value of p, which is equal to 4, satisfies the equation. So kindly follow the steps, and so you're seeing that affirms that the value of p, which is equal to 4, satisfies the equation. Okay, so thank you for watching. Follow the steps and subscribe to this channel for more videos. Okay, see you in the next video. Bye bye.